Good day, everyone. This is your research teacher, Sir Jesty, signing in today. And as I promised in our previous virtual class, last time that we had our third virtual class, I promised you to teach you statistics calculator. And I hope that you have already downloaded this in your mobile phone. And mind you, everyone, this is very important. And this is very useful as you make decisions whether you're going to accept or reject your null hypothesis later on in the conduct of your research. So ano pang hinihintay natin? Tara, let us learn statistics calculator. And let us have first our review of our previous lesson before we dig deeper into the discussion of this statistics calculator. Um, in our third virtual class, you learned that the population is very large, and if the population is very large, it's very difficult for a researcher like us to conduct our study. So it is suggested that you get a sample out of the population for you to save time, money, effort, and energy. And the next question will be, how are you going to get the sample? You can get the sample by using the suggested Sloven's formula, or that is called Sloven 1960 or Yamani 1967 formula. And the formula is about getting the sample size. It can be determined using the formula population size, big letter N, divided by 1, which is constant, plus capital letter N, which is the population size, and letter E, which is the margin of error. I hope you could still remember the margin of error. We have 1%, 5%, and 10%, but 5% is the most used, the most widely used um, margin of error, and that is to the power of 2. And after getting the number of, or the sample size, um, you must be organized. You must have an idea how to identify and determine those respondents after you finalize your sample by using the sampling techniques. So sampling techniques can either be non-probability or probability sampling. Under non-probability sampling, you have their convenience sampling, referral or snowball sampling, purposive judgmental sampling, quota sampling. We have simple random sampling for probability sampling. We have systematic random sampling, stratified random sampling, and cluster random sampling. Um, the difference between the two, which we highlighted in our previous lesson, is that probability sampling is randomized, and the all members of the population, they have the chance to get involved with the study. Otherwise, um, non-probability sampling, that gives us the idea that not all the population will be given equal chance to participate in your study. So that's the major difference between probability and non-probability sampling. So I hope you could still recall our lessons in sampling. Now, let us proceed to our main topic this day about statistics calculator. So again, I hope that you have already downloaded this in your phone so that makisabay na lang kayo while we are discussing, while you are watching this video. You can also have your hands on with your phone. So again, class, welcome to our discussion about statistics calculator. I hope that these images in front of you are familiar because you have already downloaded, as I've told you, as I've said already, you have already downloaded the mobile application. So before we proceed to the computation using the statistics calculator, please take note of the difference between p-value and the alpha. So the p-value or probability value is known as the level of marginal significance within the hypothesis testing that represents the probability of occurrence of the given event. The p-value is used as an alternative to the rejection point to provide the least significance at which the null hypothesis would be rejected. Well, in your mobile application statistics calculator, it would be very clear there that the p-value will be shown after the computation. Klarong-klaro yung p-value doon. And as the statement goes that this will become the basis whether we accept or reject the null hypothesis, and that's correct. Just pay attention to the p-value as we compare that to the alpha, because alpha, which is also known as the level of significance, is a value that we set to determine statistical significance. It will be our standard as we calculate the p-value to make decision whether to accept or reject our null hypothesis. So this is our this table shows how to make decision based on comparing the p-value and the alpha. So if the p-value is greater than the alpha, and we will be using 5% level of significance, we can also use 1% and 10%, but I will teach you, we'll be using 5% in our subject since this is widely used and widely acceptable. So when you use 5% alpha, that is also equivalent to 0.05 when you multiply it with 100. So 0.05, if the p-value is greater than the alpha 0.05, you're going to accept the null hypothesis, meaning there is no, you agree, you accept that there is no significant difference. If the p-value is less than the alpha of 0.05, you reject the null hypothesis, meaning you don't accept, you don't agree with the null hypothesis, that there is no significant difference. Rather, you say you reject null hypothesis, that means there is a significant difference with the two groups. Okay, so we'll be going back to this table as we use the statistics calculator, because this table will be very useful as we make decision as whether to accept or reject the null hypothesis. So do not forget this discussion we had in our last third virtual session. Again, if there is one group and there is one test, one kind of test given 2 times, that's the parametric t-test that we're going to use, or the parametric test that we're going to use is the paired samples t-test. If it involves 2 groups, one kind of test given at once only or one time, you'll be using independent samples t-test. If there is one group, one test given once or one time, that will be one sample t-test. But do not forget, there is the population average or population mean. Okay, do not forget that. Let's have this problem. Is there a significant difference in the weight between the girls of section garnet and section gold? So we are now comparing the female weight of section garnet and section gold, and we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 respondents from garnet section and another 12 respondents from the gold section gold. We measure their weight, and this 47.38 is the average or the mean of all the weight that we have from section garnet, and 39.90 is the average or the mean of all the weights that we have in section gold. So as you could see, there is a big difference if we compare the mean of the section garnet and the mean of the section gold. We have 47.38 for section garnet and 39.90 for the section gold. Now, the problem is there a significant difference in the weight between the girls of section garnet and section gold? To formulate your hypothesis, and I will let us give emphasis on null hypothesis, because later on this null hypothesis will be the one to be accepted or rejected by us depending on the p value that uh, we will compute using the statistics calculator. So there is it's in negative statement. There is no significant difference in the weight between the girls of section garnet and gold. So first, before we use before we go to statistics calculator and decide whether to use when to use independent t-test, paired samples t-test, or one sample t-test. Again, I want you to determine how many groups there are, how many groups are there, um, how many tests, how many kinds of tests, and the number of times the test um, was given. So in this problem, is there a significant difference in the weight between the girls of section garnet and section gold? There are two groups, section garnet and section gold. The test is the test of their weight. We measured their weight, and it's given once only for each group. And that is why we say one time, because it's given once per group. So if that is two groups, one test and one time, therefore it suggests us to use independent t-test. Okay, so I hope you have with you your statistics calculator. So open your statistics calculator and click start. So again, that's independent samples t-test. We have two groups. Group 1 has 12 participants. For group 2 has 12 participants also. And we have for group 1, we have 39. Then you have 42.5. Next is 43.9. Then we have 47, 41.2, 52. Let's key in 49, 53, 58, 58, 47. Okay, the 11th value is 42, and the last value is 54. Okay, let's move to the next group, the second group, gold for female. We have 41, 37, 41.5, 42, 35, 37, 42.6, 38, 44, okay, 42.7, 41, 37. Okay. And there you have it, the result. And you have 12 participants for group number 1 and group number 2. You have the mean of 47.38 for group 1 and 47 and 39.9 for group 2. Standard deviation, it tells us how far or close the figures are, but I will not give emphasis to this. Rather, I will give emphasis on the p-value because I will teach you how to decide when to accept or reject the null hypothesis by just looking at the p-value. Okay, so the p-value, as we compute it using the statistics calculator, is equal to 0.001. And again, do not forget that the alpha that we decided to use is at 5 levels or 5% significant level. So we'll be using 0.05. Okay, so looking back to the table, if the p-value is greater than 0.05, then we accept the null hypothesis. If the p-value is less than 0.005, then we reject the null hypothesis, HO. Again, our null hypothesis is there is no significant difference in the weight between the girls of section garnet and gold. Since our computed p-value is 0.001 and our alpha again is 0.05, it showed that 0.001 is less than 0.05. Therefore, our decision in our hypothesis or null hypothesis is we reject it. Therefore, we reject the null hypothesis that there is no significant difference in the weight between the girls of section garnet and gold, meaning there is a significant difference because we reject the null hypothesis. So 47.38 and 39.90, we could say that after computing the p-value, their difference is significant. Okay? Their difference is significant. Now let us proceed to the next example. Is there a significant difference in the weight of section garnet girls before and after 1 month of implementation of feeding program? So imagine that the school implemented a feeding program for 1 month and we have the same group, same respondents. Um, before the feeding program, these are the weight of our respondents. We have 39 to 54. And after 1 month, after the feeding program, this is now their weight. Okay, so you observe that there is a difference, but we are not in, we don't have the, um, we are not in the right position yet to say that the difference is significant. Not unless we compute it or we get the p-value and compare it with our alpha, which is 0.05. So you observe that there is a difference, but to say if that is significant, it depends on the p-value that we will compute using our statistics calculator. So first, let us find out what kind of test we will be using. So in this problem, we have one group, of course. There's only one group that we tested before and after the feeding program. How many kinds of tests? We have one kind of test. We only measure their weight. And the number of times that we measure their weight, the number of times that we conducted this test, we conducted this twice, that is before and after the feeding program. So we'll be using, again, if that is one group, one test, and done twice, we will be using the dependent samples t-test. Okay. Now let us compute for the p-value using the dependent samples t-test. Dependent samples t-test or paired samples t-test. We have 12 as our sample size. We have 39 before the feeding program, 41 after. Second respondent, we have 42.5. Then after, we have 46.5. The third respondent had 43.9 kilograms. And after eating much, she became 47 kilograms. Then we have 47. From 47 kilograms, turned to 49. We have 41.2 to 46 kilograms. Another is 52. After 1 month, she became 54 kilograms. Next is 49 kilograms, and from 49, she weighed 53.5 after 1 month of feeding program. From 53, turned to 57. From 58 to 61. From 47 to 53.4. Then weighing 42 before, she weighed now 49. So she gained 7 kilos. From 54, she gained 58.5. Okay. And here's the result. Take note that the p-value is 0. Again, though we observe that there's a difference, but to say whether that is significant or not must be computed. Since the p-value is 0 at the alpha of 0.05, again, since the p-value is 0 at the alpha of 0.05, let us go back to the table. If the p-value is greater than 0.05, accept null hypothesis. If the p-value is less than 0.05, then reject null hypothesis. It showed that the p-value is 0 and the alpha is 0.05. Since 0 is less than 0.05, so we reject the null hypothesis. Meaning that the null hypothesis saying there is no significant difference in the weight of section garnet girls before and after the feeding program, it is rejected. And we could say that the result is significant. There is a significant difference in the weight of section garnet girls before and after the feeding program. So the result from 47 to 38, 47.38 to 51.33, the result is significant. Let us proceed to the next example. Here's the problem. Is there a significant difference in the weight of section garnet girls compared to the average weight of grade 8 female population? Take note that there is an average weight of grade 8 female population. So let us have our null hypothesis saying there is no significant. Again, let us always use null hypothesis. It is suggested to always use null hypothesis. There is no significant difference in the weight of section garnet girls compared to the average weight of grade 8 female population. So we have here now the weight, 47.38, compared to 46 kilograms of the average population of all the grade 8 learners. So this is now the average or the mean. We're going to compare 47.38, whether the difference is significant or not. So again, there is one group, one test, given only once, but take note, there is a point of reference of the mean from the population, which is 46 kilograms. So to compute that using the statistics calculator, let's start. That is one sample t-test. One sample t-test. The population mean is 46 kilograms. So key in 46 kilograms or simply 46. 46. And How many sample size do we have? We have 12 sample size. Click OK. Then the value, we have the first value, which is 39, 42.5, 43.9, 47, 41.2, 52, 49, 53, 58, 47, 42, and 54. Click OK. Okay. So again, we have the sample size, the sample mean, 47.38, and the population mean, which is 46. So we computed already the p-value. The p-value is 0.436. Okay, 0.436. So the p-value is 0.436, and the alpha is 0.05. Let us see the table. Let's visit again the table. If the p-value is greater than 0.05, accept null hypothesis. If the p-value is less than 0.05, reject null hypothesis. Since the p-value 0.436 is greater than the alpha or level of significance, which is 0.05, then we reject, we accept the null hypothesis. So we agree that even if the garnet female weighs 47.38 compared to the 46 kilograms of the overall average population of the grade 8 learners, the result is not significant. Meaning, we we support the null hypothesis because we accept the null hypothesis. We support the null hypothesis that there is no significant difference in the weight of section garnet girls compared to the average weight of grade 8 female population. Okay, so now it's your turn, and I hope that I'm going to give you maybe 5 to 10 minutes. Please pause the video and continue it after you finish answering this question so that you can compare your answers. So pause the video and continue and compare your answers after you are done. In 5, 4, 3, 2, 1, start. Okay, so I hope you got the correct answers. Again, the problem is there a significant difference in the academic performance of the learners who are ML players and non-ML players? You have their grades in the first quarter for the ML players, and I also showed you the first quarter final grade of the non-ML players. The average for the ML players is 89.2 and for non-ML players is 89.6. Now for question number 1, what is your null hypothesis? So you're just going to make use of the problem and state it using the null hypothesis. There is no significant difference in the academic performance of the learners who are ML players and non-ML players. Did you get it correctly? I hope so. For question number 2, what parametric test are you going to use and why? So the answer is independent samples t-test. Why? Because there are two groups, ML and non-ML players. One test, we get their first quarter final grade, and we measured only once. It is measured only once per group. So that's independent samples t-test. And what is the p-value? So I hope you're good already in using the statistics calculator. And the result is the p-value is equal to 0.714. With the alpha of 0.05, what is your decision with the null hypothesis? So since 0.714, our p-value is greater than the alpha or level of significance 0.05, you accept the null hypothesis. So we failed to reject the null hypothesis. Rather, we accept it. So we agree and we support the null hypothesis that there is no significant difference in the academic performance of the learners who are ML players and non-ML players. So I hope that you learned much today, and I hope that you are now good in using statistics calculator and also in determining when will be the time you reject or accept the null hypothesis by just comparing the p-value with the given alpha 0.05. Thanks for watching. Keep safe.